You know that electricity is a flow of electrons through conductors like wires or PCBs and is quite similar to the flow of water in some respects. All conductors have free electrons. These free electrons are loosely held to the atoms and therefore can move freely from one atom to another. The movement of these electrons is usually random. However, if a force in the form of an electric voltage is applied across a conductor, all the electrons start moving in the same direction, resulting in an electric current. The electric voltage is just like pressure of water or air. More voltage, more current. An electric resistor is like an obstruction or a tap which decreases the current. Electric current can be a flow of electrons, always in one direction, in which case it is called a direct current or DC. Or it can be for a fraction of a second in one direction and then for another fraction of a second in the opposite direction, when it is called alternating current or AC. The dry cells give DC, and the power we use for the lights and fans is AC.
Can an electrical appliance work on AC as well as DC?
No. Normally, electronic gadgets like transistors, televisions, tape recorders are designed to operate on either AC or DC.
But some transistor radio sets can work on AC as well as DC?
Yes, indeed. But they have a battery eliminator built in, which converts AC into DC.
How does the battery eliminator do that?
By letting electrons move in one direction only. A semiconductor device called a diode allows us to do that.
What is the semiconductor diode?
A semiconductor diode is made up of a semiconductor metal like silicon or germanium, which are doped with some other elements like phosphorus or aluminum. There are two kinds of semiconductors, N-type and P-type. A diode is a piece of semiconductor which is on one side N-type and on the other P-type.
But how does it allow electron flow in one direction only?
It may be a bit difficult, so follow carefully. You know that everything is made up of atoms, and atoms are made up of electrons, protons, and neutrons. The electrons move around protons and neutrons, which are located in the center, like the sun in our solar system. A metal conducts electrons because the electrons which are farthest away from the protons and neutrons are loosely held to the atoms of the metals and therefore can move from one atom to another easily. In semiconductor elements, the outermost electrons are not so free, so these elements cannot conduct electricity easily. For example, silicon atoms have 4 such electrons, which are shared with other silicon atoms, as you can see here. Now, if some phosphorus atoms, which have 5 outermost electrons, are added to this matrix, then this one electron extra is more free and can help in electric conduction. This is called doping of silicon with phosphorus to make N-type semiconductor. To produce a P-type semiconductor, the semiconductor metal is doped with aluminum, which has only 3 electrons in its outer shell. This produces sites in the matrix which have 1 electron less. Such sites are called holes, which can be filled up with electrons. The holes in a semiconductor help in electric conduction by a different mechanism, as you see now. Here, as the holes move backwards, the electrons move forward.
I still do not understand how a diode conducts in one direction only.
I'm coming to that now. As I have already said, a diode has a p-n junction, which means it is on one side p-type semiconductor and n-type on the other side. Now, if we connect a battery to the diode in such a way that the positive terminal of the battery is connected to the p-type semiconductor and the negative to the n-type, see what happens. The electrons from the negative terminal of the battery overflow the n-type semiconductor, and after crossing the junction, combine with the holes in the p-type semiconductor. The hole current is also in the same direction. So, there is a net flow of electrons from the negative terminal to the positive. That is, an electric current flows. But see what happens in case we connect the positive terminal of the battery to the n-type and the negative terminal to the p-type. There is no flow of current. Now you explain what happens if we connect an AC source to a semiconductor.
The diode will conduct when connected with forward bias, and it will not conduct electricity in the reverse bias.
Let us now see some diodes and understand what they do. See, this is a battery eliminator. The diodes are here. And here in this tape recorder, diodes are used to rectify AC into DC because the electronic circuit needs DC supply. The diodes we just saw in the battery eliminator and the tape recorder are called power diodes or junction diodes. They are all made up of silicon. They are used to provide DC power using AC.
How does one know which end is N-type and which is P-type?
These are the most common types of diodes used in electronics. Notice this silver or black band. The end near this band is the N-type semiconductor. In the other diodes, the upper end here is the N-type semiconductor.
Very interesting. But tell me, do diodes ever get damaged?
Yes, they do. If we apply excessive voltage to a diode, it may burst with excessive current, just like a pipe can burst if water at a very high pressure is passed through it. Each diode has a current limit, which the manufacturer specifies, and you can find out these limits from the data books. As you may guess, diodes which are used for high voltages like 100 volts or more are big in size, while the ones used for lower voltages are small. The diodes for larger currents normally have a metal casing. This helps to dissipate the heat generated because of the resistance of the diode.
What happens if a high voltage is applied to a diode in reverse bias?
Then also, the diode may burn out. In fact, one of the main specifications of a diode is its peak inverse voltage. Peak inverse voltage, or peak reverse voltage, is the maximum reverse voltage a diode can survive. It varies from 50 volts to 1000 volts or more. Now I will show you the other kinds of diodes. This is a point contact diode. It is made of germanium. It is used to filter or rectify communication electric signals which are AC. It is used in communication instruments like radio receivers and transmitters. See here, this is a point contact diode in this transistor radio. There are some special diodes also, which are for very special uses. They are made by different processes using different materials. Like this light-emitting diode. It is made of gallium and arsenic. It emits light when forward biased. They are used as displays for electronic clocks and instrument displays and level indicators in music systems. Then there are regulator diodes, also called Zener diodes. They look like ordinary diodes. They are used to regulate voltage, which means if the voltage from a source exceeds the desired voltage, then it lowers it.
How do they do it?
You see, any diode connected in reverse bias will start conducting above a certain voltage. In regulator diodes, this voltage is regulated by adjusting its chemical composition, so that the diode starts conducting at a lower voltage determined by its chemical composition. This results in a drop of voltage across the Zener diode to the desired level called the Zener voltage. Zener diodes are available for different Zener voltages. And different current ratings. The Zener voltage is generally printed on the diode body. Here you see a Zener diode used in a battery eliminator and in an audio amplifier. This is a bridge rectifier. It is made up of 4 power diodes connected to each other. It has 4 terminals and is also called a full wave rectifier because it gives rectified full waves. Then there are diodes for very special uses. Like the varactor diode used in communication circuits of television or VCR, they offer variable capacitance, as is denoted by its symbol. Here, in this PCB of a demodulator circuit of a VCR, these are varactor diodes. Then there are diodes used in the AC power regulation circuits like SMPS of a color television. They are like two Zener diodes connected in parallel, opposed to each other. They can regulate AC just as the Zener diodes regulate DC. Here you see a photodiode. It is used to detect and measure light, for example, in a camera.
How can one test whether a diode is okay or not?
By using a multimeter or resistance meter. A burnt diode will show low resistance, no matter which way you measure its resistance, while a good diode will show very high resistance when it is connected in reverse bias. This is all I have to teach in this program. Now let us recapitulate what we have learned. Semiconductor diodes are made of semiconductor metals like silicon or germanium. There are two kinds of semiconductors, N-type and P-type. N-type semiconductors are made by doping silicon with phosphorus, and P-type with aluminum. A diode is on one side P-type and the other side N-type semiconductor. Diodes conduct electricity in one direction only. They are therefore used to rectify AC into DC. There are different types of diodes: power diodes, point contact diodes, Zener diodes, varactors, light emitting diodes. A diode can be tested using a multimeter or oscilloscope. It shows low resistance when forward biased and high when reverse biased. Diodes are used in almost all electronic equipment.